I'm long obsessed with truth. Truth about universe, earth, human beings, human brain, human mind. So I took my education in science, because science describes how the real world really works. And to find agreement in a disagreeable world, there's no better way than through science. Some say if science can't know it, it's not worth knowing. Others, that science is only one way of knowing. How far can science go? How much can science discover? Are there boundaries to science? Are there truths, real truths, beyond science? Our human future hangs on these questions. What are the scope and limits of science? I'm Robert Lawrence Kuhn, and Closer to Truth is my journey to find out. I begin at MIT with Frank Wilczek, who won the Nobel Prize for figuring out the internal structure of protons and neutrons, almost all empty space. Frank, I want to ask you as a fundamental physicist to reflect on the sweep, the scope, and the limits of science.
The prospects for the coming years and decades are truly awesome. We're going to see the opening up of a new window into the universe with gravity wave detectors. So this will enable us to see some of the most violent events in the universe and also go back into the earliest history of the universe. We will find out what the dark matter is, or at least refine our ideas. In technology, I think in many ways we're at the infancy of information and quantum technology. At present, assembling computers is essentially a two-dimensional affair. It's very different from how brains work, which are messy, sloppy, and self-assembled. I think we're going to see a fusion of those two ideas so that artificial information processing will become three-dimensional and self-assembling, and that opens up the possibility of it acting with much greater power on a vaster scale, turning whole rooms, whole planets into giant brains. I think that'll come.
Wow.
The other thing that's in its infancy, I think, is the understanding of the mind. Psychology is really at the stage that physics was in at the ancient Greeks, I think. Primitive pre-ideas, pre-scientific ideas. And that's going to change. And that, I think, will change the way people perceive themselves.
I understand practical experimental limits or theoretical ones like the speed of light. But are there deep philosophical boundaries beyond which science dare not go?
I don't see them. I think the application of science can give insight into any question that makes sense. It may not give you an answer. It may tell you that the question is ill-posed or that it will only give partial insight, but I don't think anything should be ruled out. And I think in particular, as we understand the mind better, that many of the things that at present are thought to be beyond the scope of science will be illuminated by scientific insight.
Frank says nothing is off limits to science as rational thought. He finds no boundaries beyond which science dare not go. I like that. Science should show no restraint. Go for it all, Frank, and future Franks. Try to explain it all. Take your time. Do science right. Then we'll assess whether, in fact, everything can be understood, if not controlled, by science. If Frank is right, philosophy shrinks, and theology, well, theology could disappear. But is science the only way of knowing truth? In an age of science, does religion still have any role to play? I go to Princeton to ask physicist Richard Gott, who offers a fresh look at potentials and limits of science.
Well, I think science is very good about making predictions and understanding the physical world. We've learned quite a lot about the universe. We've learned how old the universe is, where we are in the universe, and so forth. But more than that, physics has gotten more ambitious. We'd like to also understand the initial conditions of the universe, just not how it operates, but also how it got started. I think a theologian might come forward and say, well, have you really answered the question of why is there a universe as opposed to no universe at all? It's easy to imagine no universe at all. So that's, I think, a question that science is not really answering or prepared to answer at the present time. But it is proper, I think, within the realm of science to ask the question of how our universe did get started. Scientists now speak of a multiverse where you can see different universes. Some of these are beyond our observational capability, but we talk seriously about them. It's an assumption of people to assume, well, the physical universe is all that you can ask about. That's an assumption. I think one of the things that we've learned in mathematics that's been very sobering is that Gödel showed that you can't prove every theorem that you'd want in mathematics with a finite set of axioms. You have to keep adding more axioms. So I think that philosophers and religious leaders and so forth are also going after the truth by different axioms and different schemes and so forth. And religion's older than science. We've been thinking about religious questions for a long time, and I think we'll continue to think about them for a long time in the future. The Copernican principle would tell us that our observation point is not likely to be special. We're not likely to be at the very end of science or the very beginning of science. You're likely to be somewhere in the middle. So we've got important things to discover in the future, like the theory of everything. The same thing's true, I think, of religion. Religion's been very old, of different forms. And so I think we'd be unlucky if we were at the very end of that epoch and science was about to replace this. The sort of humble position to take is to, people always tend to think that their field is special and more important than all the other fields. And so for me personally, although I'm very excited about what science is doing, I think that it's one of the key things that we found to help to find truth in the world, but there's other methods for searching the truth as well, and these are important. I have great respect for what the people in all the world's great religions have contributed to human thought, and so I think that's a valuable thing to explore too.
Richard assumes, based on probabilities, that we are roughly in the broad middle of scientific progress. Though even at its ultimate, he says, science is not the only way of knowing truth. We human beings seem hardwired to want to know everything, to push knowledge to its ultimate limits. That's me for sure. Science is advancing human knowledge. No one disputes this. Yet there are limits to science. Almost everyone accepts this. But are there new ways of thinking in science? Breakthroughs that bust boundaries? There's one person I seek on this. Stephen Wolfram, who proposes grandly a new kind of science. Stephen's vision is audacious. Can he extend the limits of science?
One of the things that people often sort of consider to be the great achievement of science is its ability to predict what's going to happen in some particular system. And sort of the classic example of this from 300 years ago is the motion of planets. You want to find out where the Earth will be 1 million years from now. You might think you would just have to trace the Earth for 1 million orbits. But in fact, there's a little mathematical formula that tells you this is where the Earth will be on its idealized ellipse or whatever at that time. And that's been kind of the characteristic example of what we hope to get from science, this ability to say, let's be able to predict what a system will do without just having to watch and see what it does. So one question is that really the correct model for what can be achieved in science or not? Will we always be able to take these systems and, in a sense, outrun them with our own intelligence or methods or science? And so in a sense, science has been about this kind of competition between us as predictors and observers of the natural world and the natural world itself as a thing that just does what it does. Well, one of the things that has emerged from the kinds of things that I've studied is that picture is quite incomplete, that it really isn't the case that we can expect always to be above nature in that kind of way. We sort of have to really, we get into the fundamental questions of how can we compare the processes that go on in nature with the processes that go on in our brains or in our mathematics or in our scientific theories. And one thing to do is to sort of find a way to think about all of these things together. And I think computation is sort of a convenient metaphor for all of these things. We can think about the processes that go on in nature as computations. We can think about the operation of our scientific theories, our brains. These are all to be thought of as computations. Mm-hmm. And then the key question is, how do these computations compare? Are our brains and our mathematics and so on somehow fundamentally superior computations to the ones that go on in the actual systems in nature? So one of the things that I've found is that I think that they're not. That there's this principle of computational equivalence that kind of shows that there is a fundamental equivalence between the kinds of computations that go on in the natural world and even in systems with very simple underlying rules and the kinds of computations that can go on in our brains or in our methods of analysis and mathematics and so on. So it's this principle of computational equivalence tells us that actually what we've seen so far in science is the unusual case. It's the case where things aren't equivalent in their computation to us. It's the case where the things that we see in nature are somehow simpler. They're somehow computationally reducible as compared to the more common, I think, case where the computations that are going on in the systems in nature are fundamentally equivalent to the computations that we're able to do as observers or analyzers of nature. And in the case where these things are equivalent, there emerges this kind of idea of computational irreducibility, that what happens in nature is something that is equivalent to what's happening in our brains, so we can't expect to outrun what's happening in nature. So what becomes very important then is to make the best possible simulation. Right. So that kind of puts pressure on the need to find the simplest possible underlying rules that represent a particular kind of system. Right. But this means that there is sort of a fundamental limit to what we can expect to be able to predict in science. And sort of the challenge, which I've spent many years trying to meet, is to sort of build up a new kind of science in which it is sort of taken for granted that there'll be lots of computational irreducibility, but then what can one still say in science? They're different kinds of conclusions than we've been used to seeing in science.
Stephen proposes that computation and its rules are his new kind of science. From deceptively simple rules developing over time, all the complexity of our world can emerge. But aren't these rules and their results models of reality, not reality itself? Almost all scientists are realists. They assume that scientific models represent the world. They are not themselves the world. But to Stephen, there is a fundamental equivalence between computations that generate the world and computations that drive scientific models, and that underlying both are simple rules. Stephen says that when we find the deepest simple rules, we will have reality. Key here, and for exploring the limits of science, is the relationship between scientific models and the actual world. To get at this, I go to Princeton to ask a leading philosopher of science Bas van Fraassen. Bas is a strict empiricist, meaning that knowledge must come directly from observation and data.
Bas, help me understand the scope of science and also its limits.
When I think about science, I think of it as a large human enterprise that has certain criteria of success, has an aim that is explained through its criteria of success. And as an empiricist, I say they all have to do with what's observable, that a science is indeed going to give us the best possible explanation and description of what we can find in the observable realm. That is what it is for science to be successful.
You do not believe in so-called scientific realism.
That's right.
Now, what does that mean?
Well, you see, the scientific realist will also say science is an enterprise that has a certain aim, criteria of success, but they claim that the criterion of success is truth, period. Truth in every respect. So not just about what's observable, but also about all the things that they postulate in order to explain the observable things.
So they have less distance between their explanation and some ultimate reality. You have sort of a filter there. Is that fair?
Well, when it comes to the kinds of things that in science are postulated to explain the observable things that we all experience and deal with, right? The scientific realist says, if you accept the theory, you believe that those things are real. And I say, if you accept the theory, you believe that it's empirically adequate. That means that it is adequate with respect to the observable phenomena, what we can find in measurement and observation, how we can test the theories. That is the criterion of success. I see the scientist not as discovering, like Columbus discovered America, but constructing models and theories in order to represent the observable phenomena. And it's a constructive enterprise. They construct the models that they hope will fit what we can test. So, you know, the scientific realists, they say the explanation is that it must be that the terms in the theory, even the very theoretical terms, they refer to real things. And that the statements that are made about these things, which are perhaps not observable, are true. That's the explanation for them of the success of science. The scientific realist says, we have an explanation of the success of science in terms of reference and truth. It's not a scientific explanation, it's a metaphysical explanation. You see, they step outside of science. And for an empiricist, that's not the thing to do.
And that would give you good science,
Yes.
but that would not necessarily exhaust all truth.
Absolutely, right. That is how I see it, yes. Yeah, I think that science, you know, for us, the empirical sciences, they're a paradigm of rational inquiry. Absolutely. But I do want to emphasize it's a paradigm.
Not the paradigm.
Not the only paradigm, yeah.
As a strict empiricist, Bas affirms what we can know for sure. He allows only observations and models into his system of certainty, but not the reality that generates them. To claim that science can reach ultimate truth, he says, is metaphysical, not scientific. I applaud Bas's empiricism. Human perception is indeed secondhand, though I don't quite see his anti-realist vision. Bas also suggests that there are other paradigms, ways of thinking other than science, that can also discern and know truth. Sure, I'd like ultimate reality to be more than mechanistic science, disinterested and impersonal, but what's the evidence? Perhaps the limits of science lead to other paradigms. I go to Harvard to meet Owen Gingerich, a distinguished historian of science. I know full well that Owen voices strong belief in God. I'm sympathetic, but skeptical, hopeful, but cautious.
I think it's useful to think about science in terms both of foresight and understanding. Foresight is the ability of science to predict things. It's uncanny the way the Newtonian laws of motion can predict everything from the falling of an apple to getting a spacecraft to Jupiter. But there are aspects of science that don't really link into that very well. Evolution, for example, is great on understanding and pretty limited in terms of numerical prediction of things. There is a firm psychological acceptance by the majority of evolutionists that mutations are strictly random. And it is mutations that drive the variation that makes the evolution possible. But you know, that is not a scientific conclusion. It is that the mutations, for the most part, certainly act as if they are happening randomly, but it's not something that can be proved. It may be from a theistic perspective that God, as sustainer of the universe, is in some fashion essentially subliminally making possible these mutations. The fact that we're here suggests that there has been an extraordinary process that looks as if it was guided purposefully. All I'm saying is that there are important assumptions being made, foundational ones, that are not necessarily the case.
If you look as a historian, you certainly see the scope of science increasing over the centuries, where more and more is being subsumed within the scientific way of thinking.
Sure, but in a way, science is like looking at a musical score and being able to calculate the harmonies and the overtones. You can understand all of that mechanically. You could probably write a computer program, but it probably wouldn't be Mozart. And it would not do the same thing as your psychological appreciation of the music and what it does for you.
Well, this very naturally brings up the limitations of science. What are, if any, the fundamental limits?
Well, it's fuzzy and it's tricky, but recognizing that there are limits is a good place to begin.
And some people would deny that totally, that they would say that if it's not ultimately susceptible to a scientific method, it is ultimately not knowledge. And so
I understand that's a view. It's perhaps a credo. It's perhaps coming from men of faith, of a rather different faith than mine.
Yes.
There's a whole realm, an important realm of feelings, of love, of poetry, of music, of art, that doesn't really fall under science. So I think in terms of a grander view of the universe than just what you can make with predictions, and even to some extent what you can do with understanding.
Science is humanity's monumental triumph, and I follow faithfully its way of thinking. But is science the only way of knowing? If it's not science, some say, it's not knowledge. It may be art, it may be faith, but it's not knowledge. I agree, but I also agree that there are limits to science. Keep out zones which science shouldn't enter. These zones may or may not contain truth, but they do not contain knowledge. How so? What's the difference between truth and knowledge? Knowledge is that which all human beings everywhere can accept, and only science can produce that. Truth, on the other hand, is a broader, deeper reality. There are aspects of truth that science cannot address. But even if truth, those aspects are not knowledge, because all human beings everywhere cannot accept them. Art is a matter of different tastes. God is a matter of different faiths. Science is value-free or value-neutral, which is an asset, not a liability. I want no artistic prejudices or religious biases, as science brings us closer to truth.
For complete interviews and for further information, please visit closertotruth.com.